thank you everyone for joining our workshops today on how to build modern data science prototype applications. In case we haven't met before, I'm Hui from the Hertie School Data Science Lab. I help to manage most of the day-to-day work of the lab, as well as also support with our Masters of Data Science for Public Policy at the Hertie School. It's probably quite strange today to be here, and also with the news from Ukraine and Russia. And it seems like we're going to be in another year of very momentous changes and uncertainty of the future ahead. But I think personally, I think it's in time like this that it's important than ever to not despair and think of the bigger future ahead of us, and also maybe to learn new things, to be excited about new technologies and the possibilities of what it can do and how it can help us, and also think of ways that we can use these technologies and these knowledge for the good things in our lives, and to help others that are struggling and are in need of our support right now. So with that said, let's just jump into the workshop today. Here's a very brief, sorry, let me admit a few more people. Here is the brief outline of our workshop today, and we will touch on first why we should spend some time to learn about prototyping and creating data science applications, and the different stages of data science projects, and where does this process of prototyping fit into this project pipeline. And we will also touch on the details of model deployment and the different peoples and contributors in a machine learning pipeline. And then we'll go for some examples that we can also have fun with, and also play around with the two frameworks that we will learn today, Streamlit and FastAPI. And I would like to say first that the exercises, especially the data science prototypes, they are very light and fun examples. So please don't expect anything hardcore. We'll just do some light codings and to understand Streamlits, as well as review the project codes to understand the different pipelines and how we can actually implement this in reality. And so first, why should we be concerned with prototyping? Why should we think about prototyping? And I mean, we are all here today, so probably you do not need much convincing anymore. But one common complaint that I hear quite often from colleagues, as well as friends working in the industry, is that it's actually very hard to convince people of the values of data science. And many companies nowadays, they hire data scientists and data professionals and analysts, mainly because of how they want to advertise it to their clients and their stakeholders that they are at the cutting edge of technologies. But when you actually ask the people working in these projects, many companies actually have a difficult time to understand the values of data science. And data professionals nowadays need to actually perfect the art of persuasions, to communicate very clearly and very well to stakeholders in order to answer business questions, and to be able to explain very complex results to non-data stakeholders. And a prototype, in particular, maybe a web app or a mobile app or a dashboard, for example, will not solve all of these problems. However, they will be able to help people to interact with your insights. And it's basically a first step to help others to understand what you're working on, as well as to understand the insights that you have for the data. And also, it's quite a challenge, as you probably understand, when you present a Jupyter notebook to non-data people. And so with a web app, with a mobile app, with a dashboard, it helps to bring these things to reality. It helps people to interact with the data. It helps people to interact with the insights that you have. And it also helps us to improve our engineering skills. Since a common complaint from product and engineering team for a data science team is actually data science teams are not very good with engineering. And so, we don't know how to code, and we don't really know how to refactor our code so that we can reuse these codes in productions and in other processes. And so when we actually engage in building prototypes, we can actually be a part of this process of engineering. We understand a little bit more the difficulties and the challenges of our engineering teams, and we also can also improve our code in that way so that it can be easier for people to productionalize our code and productionalize our insights into a pipeline of data later. And the last reason, and I think it's actually the most important thing, is prototyping is actually very fun. It's super cool to see your work in actions, and it's super cool to be able to create something that people can interact with. And I think it's also a blessing to be able to do this with all the frameworks that we have nowadays, because before you have to learn a lot of different things like HTML, CSS, and JavaScript, as well as maybe Node.js and all the other backend frameworks. But nowadays, it's actually quite easy with all the wrappers, frameworks that are on top of Python. And so you can easily write these things in a very Pythonic code that is easy to understand, also very easy to interact with as well. And so next is, what are some of the stages of data science projects, and how do you actually solve a data science problem? And you've probably seen this quite a lot in different presentations, or maybe in different textbooks about data science and different projects that we have in data science. And so this is just an iterations of that, and also some additional details as well. So as you can see here, we have 6 different stages of data science projects. And the first is always to understand the problems. It's identifying the business case that you want to solve, whether it's maybe something simple like what are people buying this month? Like what are people buying during monsoon season or during rainy seasons? And maybe how do you actually identify poverties in areas that do not have data from governments, for example? And so first, it always starts with a business questions or something that you want to have an answer to. And it has to be an issues that can be answered by data. And it's not just any issues. It's data science. It's as good a tool it is. It's not a bullet. I think it's not a bullet for every single problem that you can solve, but it can be a very good tool for solving data issues, especially in problems that you have a lot of data with. And so first you have to understand the problem, and then you have to set your goals and understand the issues very deeply. And you also have to work with a domain expertise in order to understand, and in order to also not go for the wrong questions and not ask the wrong questions and find the wrong answers to the problems. And once you have a very deep understanding of the problems, and you start the collections of data, and it's basically you start to identify the different data and also the different data points that can actually help you to answer the questions and answer the business problems that you're facing with. And this is usually a process that is quite tedious, and also it's very difficult because a lot of times data are scattered everywhere in different corners, and also it's very unstructured. Some are images data, some are text data, some are numbers data. And so it's quite difficult, I think, sometimes to actually collect all these data together and also to mash them together into one format that you can work with. And then stage 3, it's the exploration of the data. Once you have a data set, and once you have basically push these data into a format you can work with, then you start to explore the data. You start the exploration stage to understand what's in the data and what can you work with, and maybe what are some of the things that you can collect further in order to understand more of the problems, and also to understand more of the issues that you're working with. And this is also where you start to identify the different issues in the data. For example, there could be missing data issues, or there could be unbalanced data issues. And so you start to come up with the different strategies on how to solve them, and how to actually input imputations of the data so that you have a full data set that is ready for modeling and for engineering of features. And after you explore the data, and once you have some hypothesis of how to actually answer the problems that you are facing with, then you start to engineer the features. And it's basically the step of selecting the features that have the best predictive powers for your models. And it's this is a very delicate process, I think, because oftentimes you have data sets that have hundreds of thousands of features. And so it makes sense to actually cut them down into the features that matters, like the things that have the most predictive powers, so that you can work with a reasonable amount of data points, reasonable amount of features, that can give you both speed and also accuracies trade-off. And once you have selected your set of features that are good for the models, and you start the process of training the models and iterating over the different models to identify the best parameters for the results and also for your business goals. And as you probably know, in the last few years, I think the modeling process and the feature selection process has become quite standardized. You have scikit-learn, you have PyTorch, you have TensorFlow, and all these frameworks are now very good at building models. You can basically build models in a few lines of codes, basically. And that's why nowadays I think people often have the saying that building models is cheap, deploying them is actually expensive. And so that's why this is the stage of the situations right now, where companies are now starting to go into deployment stage, because they have realized the values of actually deploying these models into productions. And whereas before, I think in the last decades or so, it's more about standardizing the approach of data science pipeline and creating models and optimizing models. And now that we are at the stage where we probably have figured out all the best algorithms for modeling, now we start to think about deploying the models into productions and actually bringing business values from the different insights and data that we have. And deploying models is basically maybe launching a model as a web or mobile or desktop applications, or something that it's our stakeholders can interact with the data and the findings that we have from the stage 4. And after deploying the models, it's not the finished step. After you deploy the model, you have to constantly monitor the models and making sure that the models is actually doing what it's actually supposed to do. And also you have to be very careful of model and data drift. There's this thing in model deployment called concept drift, which is the idea that the probability distributions of your data changes over time. Right? So it's mainly because a lot of times when people's behaviors changes over time, depending on the different context and depending on the different events that affects their lives. So one example that we can think about is, for example, COVID. People's behaviors of purchasing items before and after COVID are completely different. And so a lot of companies that have dabbled into deploying machine learning models into productions before COVID, they actually found that their models became quite worthless after COVID happened, because people actually changes their behavior significantly, and they buy different things, and they also buy things in different regularities. And so they have to completely retrain all the models, and you have to rethink about the pipelines of the models and how what are some of the other features that can help them to predict the new behaviors of the people. And so that's why it's very important, this last stage, testing and monitoring models in productions. Putting in models into production is not the last step. You always have to monitor them, making sure that they're actually giving you the right predictions. Otherwise, you come up with the wrong predictions, you come up with the wrong forecast, and it can actually have a very detrimental effects on your business and on the values that you can bring to your customers. And so the first 4 steps is actually what is often covered very often in a lot of data science and also machine learning curriculums. And the stage 5 and stage 6 is actually the things that are not very often covered. And mainly because I think in the first 4 stages, the things that are standardized and the things that you can actually replicate over and over again, and it actually works and it actually makes sense. And stage 5 and 6, it's something that is still not very standardized. Every company does them differently. If you go for Netflix and Facebook and Google and Amazon, all these companies deploy their models in different ways. They use different frameworks, they use different pipelines, and they even build their own pipelines and their bespoke solutions in order to deploy models. And so different companies have different standards and different ways to deploy and monitor their models. And so that's why it's very difficult to actually nail down one particular way of doing so. And but this is actually what makes it also very fun, because when you actually learn one way of deploying models into production, especially if you deploy it to cloud services such as Microsoft Azure or Google Cloud Compute or AWS, then it's also very easy that you can actually transfer this skill to other platforms and other models and other ways of deploying models as well, as long as you understand the basics. And what about the contributors in a machine learning system, we have in an ideal world, so we would have 5 different people, or at least 5 different teams that can help to handle different things in a machine learning system. So first, you always need to have a domain expert, someone who understands deeply the problems and understands deeply the business issues that you're facing with, so that you can always refer back to these people for questions and for clarifications of the things that you are not understanding about the data, for example. And the domain experts would work very closely together with the data engineer and the data scientist in order to create a pipeline. So the data engineer job is basically creating data pipelines to collect the data from different sources, especially unstructured data, and actually like how to actually bring all these data sources together into a pipeline, and how to actually manage them and how to actually process them, so that you can create a format at the end that the data scientists can start to explore and analyze and model the data on. And so a lot of people, I think, have a mix of understanding between data engineer and data scientist. So a lot of times in companies that are working with a lot of data, with a lot of customers, they have very dedicated data engineering team that specifically just focus on handling the data pipeline. So they just handle how to actually find the data, how to identify the data sources, how to actually impute all these data sources into one pipeline, and how to process these data sources so that you can create one format of the data, maybe in a CSV file or in a database where you can query the data. And then the data scientist job is just analyzing the data, querying the data from the database, and then modeling the data, analyzing the data, choosing the models, choosing the parameters for the models. So that you can have the best possible chance of creating values for the business. And then once the data scientists have chosen the models that they want to deploy to productions, then they bring that models into the machine learning engineers. And the machine learning engineers would take the Jupyter notebook, for example, that the data scientists have created, and then they will refactor the code within these Jupyter notebooks into code that can be used in a production pipeline. So the code that you write in a Jupyter notebook, usually it's quite messy because you experiment a lot with the different models, and you also write things out to test them very quickly, and you can iterate very quickly with different models from different versions. And the machine learning engineer's job is basically come into that mess of code and then take out all the things that matters the most, like for example, all the functions, all the classes, and refactor them into different codes and different pipelines so that you can start to push them into productions. And then the DevOps engineers is basically the ones that are taking care of the whole pipelines on how to actually continuously deliver the product to the end users without any breakage in the system. So for example, you deploy a machine learning models in the system, and then maybe after 1 month, you realize that the model is now deprecated and you need to update the models with new data. Then from the data scientists, they would push the new models into the machine learning engineers. The machine learning engineers would then try to debug the models and making sure that everything is good, and then they would push that into the DevOps engineers, and the DevOps engineers would make sure that the models is deployed, and when it's deployed, the users from the previous models will not be affected, and then will be gradually transferred to the new models state. And so this is the whole pipeline, I think, of all the different contributors in a machine learning system. And this is the ideal situations that we have, but life is not a dream. And so oftentimes all these different roles and all these different people are just one person, just the data scientist, and or maybe one team. Hopefully then you have 3 more people to help you with. But because a lot of companies nowadays, they do not work with, I think, a massive number of clients, then usually they just have one data scientist or one data analyst to help to take care of the whole pipeline. But if you start to have critical mass in terms of number of clients and the number of your customers, then you will need to have a proper team like this in order to make sure that the whole pipeline is taken care of. Otherwise, if you have just 1 or 2 persons taking care of the whole pipeline, then they would not be able to take care of all the different matters and all the different functionalities. And so you would have breakage in the system, you would have security issues, and you would have models that are not actually giving any value to the business. And so this is one thing to, I think about when you think about maybe bringing values into the business. And when, for example, when you start to build up your data science teams, or when, for example, when you work in your projects and then you think about like who's taking care of what, and it might make sense to break the different parts and the different functionalities of a project into different roles so that each of you can take care these rules in a more efficient manner. And so we talk a lot about model deployment. What is it exactly? So it's simply putting our trained models that we use into cloud or in some system where it can be easily accessed by other system in the business, so that it can actually create predictions and forecasts to bring about business values. And so for model deployments, you have, I think, a number of concerns you have to deal with. And first is the reproducibility of models. It's basically the ability to replicate machine learning models, and it's using code versioning, basically. It's very similar to how you use GitHub to have different versions of your code, and you can always come back to the previous versions, for example, in order to understand maybe some of the issues that you have, or maybe some of the bugs that you have in the new models. And so versioning of models and versioning of the data is also very important, so that it helps with the reproducibility of the machine learning models. And also it helps, especially when you work with a big data team and everyone is working on different models and different versions of the models and different versions of the data. Having an overview and having the ability to monitor all of this would help you a lot, so that you do not basically come into the issues of people pushing these different models into productions, and then you have conflicts of models and conflicts of data. And I mean, you can, I think the simplest way that you can do this is just basically using a spreadsheet, right? You can, for example, you can record all the different parameters, and you can record all the different data points and all the different models and different error rates that you have once you've trained the models, so that you can see over time all the different models that you have, that you can also retrain them in the different checkpoints that you have. But nowadays, we actually have a lot of automated platforms that can help you to deal with this issue. So for example, weights and biases, and also MLflow is two platforms that I can actually recommend. It helps you to, and this is actually something that you can actually integrate into your Codelab and Jupyter Notebook as well, where you sign up for these free platforms, and when you train a model, all the model parameters and model predictions and also the error rates and the accuracies are recorded into these platforms automatically, so that you can always come back into these platforms, and you can look at your accuracy rates, and you can look at the different models that you have trained, and then you can select what are the models that are best for your business goals. And so I highly recommend, if you're working on a machine learning projects, to use this to basically record these different things, so that you can use that for your reporting is one thing, and also you can use that in order to make sure that you are able to come back to a models, for example, that might be more successful than the model that you trained at the later stage. And the next three important thing is the automations, extensibility, and testing, especially something that has to do with how you can actually continuously retraining and retesting the new models that you come up with. And so I mentioned earlier the step 6 about testing and monitoring models in productions. And this is basically the idea that you always need to retrain your models over time. So once you deploy a model, you then maybe you monitor it during productions, and you see the accuracy rates and whether or not, if it drops over time, then you will start to have to look into the data. So you have to actually start to look into the problem again, and to see whether or not it is part of the model's problem or it's part of the data problems. And either way, you will have to retrain your models, and either way, you will have to extend your models to a different versions, and you have to test this model again in a new settings in order to make sure that everything is working as expected, and everything is actually not breaking the product for the users. And then the last two issues is modularities and scalability issues. And modularities is something I mentioned earlier about breaking your codes into chunks and breaking your codes into basically different modules, and refactoring your code so that you can reuse them in different pipelines. And this is basically helps you and also helps the engineers to easily engineer the solutions at the later stage. So that, I mean, it's very tempting, I think, and when you're working with Jupyter Notebook, you just write whatever, right? So you just like write whatever the code that comes into your mind, and whatever analysis that comes into your mind. But it helps you a very long way if you actually create, for example, proper functions and proper classes, so that you can reuse them over and over again. Because you will you will come into these issues when you work in a real settings later on, when you see that all the projects follow the same pipeline. All the projects are you doing the exact same thing over and over again. And so if you create a pipeline with proper functions that you break into modules, and you create different classes that you can reuse over and over again, it reduces significantly the amount of work that you will have to do. Otherwise, you will have to write the same Jupyter notebook over and over again. And it's really a waste of your time and also a waste of the engineer's time to actually refactor this code over and over again. And then the last is the scalability issues. And this is something that has to do, especially if you work in companies or in a product that has a massive amount of users, then you have to think about your servers, right? You have to think about how to actually serve models to people and how to actually update these models in a way that is scalable, instead of update the models and then it breaks for some users and it doesn't break for some users. And with that also comes with security issues as well. Like, how do you actually make sure that the models and also the server that you have is secure? And it's also the issues of speed versus accuracy, because one thing that a lot of companies have to face with is the trade-off between the speed and the accuracy of the model. If you want accuracies, then you would have thousands of data points and thousands of features to help you to predict the best possible model, best possible predictions and forecasts. But this basically comes with the trade-off of speed, because if you have hundreds and thousands of features, then it takes a very long time for the model to do inference and to do prediction on this. And so a lot of times what the companies do is just basically reduce the number of features by doing a principal component analysis in order to make sure that they only select the best possible features. And then with that, you reduce the number of informations that is existing in the models. So you can reduce the size of the model, you can increase the speed, but then with that, you also reduce the accuracies, because you lose a certain amount of data, you lose a certain amount of features that might otherwise help to contribute to the prediction power of the model. But we do not have to worry about all of this today, fortunately, because we are only working on prototypes. And so for prototypes, it's basically just a very quick and dirty way to test the models and to test the data that you have, and to make sure that the insights and the models that you have can be used by real users, and also for maybe your clients to easily and to quickly check with the progress that you have in the data, with the progress you have on the business questions that they have. And so today we work basically on the prototypes of your data science projects. It's good for demo exercises, but not for usage by mass users. And this is actually a very real issue that I come across when I create the different models for this workshop, because this morning I look at my model again, and all of them actually went down because the servers was not able to handle the load of the models and the weight of the model. So so these are basically just prototypes, and so it's very it's very recommended that you use very lightweight frameworks, and you use very lightweight models so that you can launch them easily and people can use them in an easy way. And then next, in the next two workshops that we have for this semester, we will also focus on how to actually deploy this on mobile applications. And for example, in the mobile applications using the Flutter framework, and especially building machine learning and deep learning power mobile apps. And for these apps, you can actually use both for demo and also for usage by mass users, because once you have created an app on iOS or in Android, you can easily deploy them into the App Store on both frameworks, and then the users can easily download and use these things. And for model testing and monitoring in productions, this is probably the most difficult part of model deployment. And this probably will take a little bit of time. And so we will try to organize something like this sometime in May or in June, so that you can also understand the full process. So one thing to note is that you probably will not have to worry about model testing and monitoring in productions, but it's very, I think, useful to know, and especially if you work with the engineers that will have to take care of this process, so that you know their pain point, so that you can make sure that once you create the models and once you basically launch these models to the machine learning engineers, that they are able to create the different testing and the different monitoring pipeline for these things. And for the frameworks that we work on today, it's the two main frameworks. Is one is Streamlit, and the second is FastAPI. So Streamlit is basically a framework that can help you to easily create web applications in just minutes. And we will see, I think, in a few minutes, Streamlit. Before, I think I mentioned that we have to learn HTML, CSS, and JavaScript, and all these web applications language. But nowadays, for data science teams, it's usually you can just use Streamlit to launch a lot of your prototype applications, and it's very easy to use. You can write it in just a few lines of code, and you can launch your models very quickly. And then for backend, you can use FastAPI. FastAPI is a very new framework. I think it just launched in the last few years or so, but then it's quickly become one of the most famous frameworks, I think, for deploying machine learning models in productions. So Streamlit is for prototyping, for demo exercises. With FastAPI, you can actually use it in production pipeline, because it's API, for some of you that may not be aware of. It's basically a way that you can use for two business applications to talk to each other. So for example, my laptop, when I use the browsers, and when you browse the web, for example, and then you go to a website and you query, for example, Facebook on a particular user's image, you click on an image, and what happens usually is that Facebook has an API. It's basically a worker, a helper applications interface that receive the request that you have. Like you click you clicked on the image, and your browsers send a request to that API, and that API receives the request, and it asks the question to the database that Facebook had on what is the image that you have here? Like, can you give me the image that the user is asking for? And then the database respond back to the API with the image and with the link, and the API then sends the response back to our browsers, and then our browsers actualize that image in our browser so that we can see the image. And that's basically the idea behind API. And API backend for machine learning models is basically you store the models in a storage space. It could be a database, or it could be just a file folder in your computer. And then the FastAPI is basically the helper that stands in front of your model. And whoever application that asks for queries the models so that it can start to inference and create predictions, then the FastAPI receive that request, query the models in the database, and then receive the answer from the database, and then transfer that response back to our apps, so that we can know the answers and know the inference points. And I think we can go and look at 3 different apps today. Hopefully we have enough time to look at how these apps are used and how they are written. So I have 2 examples that we can look at today very easily. So one is this is something that I wrote very quickly yesterday, and this is basically a problem that I've been struggling with personally, because I pay very high rent for my apartment, and so I very often I ask myself the questions like, is it worth it to buy or to rent an apartment or a real estate here in Berlin? And there's a lot of, I think, guides on the internet on how you can maybe calculate all of these things, but then I haven't seen any calculators that helps you to actually like calculate your net worth like over time, and to see whether or not it actually makes sense to buy a house or to maybe just keep renting. And so that's why I thought this could be a good examples of how you can actually use Streamlit to actually just build this this very simple app. And so the way that you use this app is very simple. So there are some default values in here. For example, if you want to buy a real estate or a house for about 300,000 euros in Germany, and how much down payment would you be willing to put down? Like, so it could be like 20,000, it could be 5,000. Usually, as I understand, you can actually loan out 100% of your purchase fee. So you can actually like buy a house like 300,000 euros, and you can actually loan like 300,000 euros, borrow 100,000 euros from the bank. And so their interest rates, as I understand, in Germany is quite low right now. It's like 1.5 or 1 at the moment. So you can toggle with all this, and like how long do you want to pay and how long do you want to set your repayment period. And then we also think about the housing market annual appreciations, because we know that there are different, the housing markets is basically increasing values over time. Right? Johanna, you have a questions?
Yeah, I was just wondering, should we be seeing something else than the slides already? Or
okay, you're not seeing it? Okay.
No, we see your presenter's version of the slides at the moment. Sorry to interrupt.
No, sorry, no. Sorry, I have probably to share this again. So that, can you see it now?
Yes, yes. Thanks.
Okay. Yeah, so so this is basically the app that you can basically create with Streamlit, which is like a very few lines of code. Yeah, so as you can see, as I mentioned, like you can toggle with like the amount of like whatever the value of your house that you want to buy, so like 300,000 and 400,000, and you can actually have a very nice chart to show you like your net worth over time. So there are 3 factors that I take into account when I create this app. So 1 is what happens when you buy a property. 2 is what happens when you just rent and you save money. And 3 is what happens when you do not save, but you use the money that you are supposed to save to invest in a medium deal assets. And so you have 3 different possibilities. And so you can actually use this in 2 different ways. Either you can compare the different scenarios and how to actually manage your money and how you actually benefit you the best. Or you can also have an overview of everything that you work on, right? So you can think about that. You can actually be buying at the same time. You can also be saving at the same time, and you can also put some money into investment as well. And so you can do it both ways. You can do this as a compare, so that you can see like which one is the best, or you can do it as just an overview of everything that you have so far. And so this is an example of maybe 300,000. So it's a little bit more of a price range. And we have the down payment, and we have 1% interest rate. So usually, we just set it to 30 years so that we can have a longer horizon. And then the housing market and new appreciations, like I think last year was around like 10 or something, but then I think with the market right now is actually quite bad, and also with the news of war and uncertainty, I think it's probably going to go down. So I've just put it +5. And what about savings? So my own, for example, if I pay maybe 1,000 or $900 for 900 euros for your renting, then you really don't have a lot left, I think, in savings. And so just put like 500. And so what happens if you maybe put some money into investments, and so we can put like 600 euros, and then you can also toggle with the expected investment return per year as well. So as I understand, in Germany, if you invest in ETF and if you invest in, I think, stocks and bonds, it's not really a lot. Like I think it's like 1 or 2% per year. But if you invest in, I don't know, like if you are high risk investors, like me, I tend to like go a little crazy, and you can maybe like go into crypto, and you can go into like other speculative assets as well. And so you could get like 10 or 15 or even 16% per year. And so as you can see here, as we toggle with this, you can actually see that the net worth of whether you buy a house or you invest or you save changes over time. So with a 10% annual yield for investment, you can actually start to catch up with your purchase of housing like in 30 years time. So and then you can have the net worth in the number of years as well. So this basically depends on the number of years for the repayment. So if you set it as like 17, and it only has 17 years. And for that, as you can see here, it always makes sense to buy a house. Like that's what I realized. And this is also something that I realized when I talked to a lot of my colleagues and my friends who have actually retired. Buying a house helps you significantly once you retired. Because you do not have to worry about all the housing expenses, and like all the people that I know that can retire comfortably, they all buy houses. And so this network chart also collaborate with that, I think, argument. And so as you can see here, if you just save, then you really do not have a lot, I think, over time. But if you either invest or if you either buy a house, then you actually have a lot more. And what about the code? Like, what does it actually look like when you look at the code for this? Let me reshare so you can see the code as well. Yeah, so this is the code for the net worth calculator. Yeah, so it's very simple, right? So I can probably expand it maybe with both screen at the same time so you can see more clearly. Yeah, so as you can see here, you just basically import the Streamlit. Everything here is written in Python. And so we'll see 3 levels of messiness of code. So this is like the messiest level, right? So this is what you usually see when you work in a data science project in a Jupyter notebook, right? You just write whatever and you don't really care because everything that you can see what happens. And so, yeah, for example, you can see here, if you want to have the titles, you just basically have import Streamlit and you just Streamlit title and the net worth calculator, and then it will appear here basically. And you just want a paragraph, and you just SD write, and then it basically create this thing for you. And if you want an subheader instruction, it's basically like this. And if you want a sidebar, then you just basically call the Streamlit functions, and you call the sidebar functions, and you call subheaders, and you have purchase price here. And so it's very similar to, I think, how you build up a Python projects. So for example, here you have the user input as well. You can either have number inputs or you can also have text input. And so for here, I put number inputs as the price of real estate purchase and yeah, down payment. And you can also have slider. So as you can see here, everything is it's a wrapper function. So it's very easy to write. Once you put everything down, and it's just basically, it create a very nice and neat app for you, so that you have to worry about the like, yeah, HTML, CSS, and all that fancy stuff. And then like, for example, how do you actually create like all the data frames for this? And so it's very usual as you usually create a data frames for Python, right? So you just write very simple Pythonic code to create your data frames. You create the column. For example, here I create an empty data frame that holds all the years, depending on the repayment period. And then yeah, here's the saving. Yes, Johannes?
Yeah, question more generally, where does this run? If I'm running like your API as me, does it use your computer to run this, or where is it?
Yeah, so you can actually basically launch this app into like a server, right? So you can launch this locally, and it will basically use your local servers to use this. But if you want to launch this so that other people can also see and other people can use, then yeah, so you can basically go for Streamlit.io, and you can sign in. Yeah, it's free, so you can actually build these apps in Streamlits, and then you can actually yeah, you can just basically new apps. And then if you have a GitHub repo, right, so you basically have to push this project into a GitHub repo, and then you basically push that in, and you choose the branch master, and then like the file that you have where you write the codes, usually like Streamlit app or like main py or something, and then just deploy, and then it's online, and then it's using a server from Streamlit to actually host these applications so that other people can use as well. And yeah, I'll send like all these like prototypes later, so you can also play around with this, and you can also even like suggest I don't know, pull requests, and you can improve on this as well. Yeah, so for example, like all this, I basically use this I don't know, this formulas for investment, and also the formulas for calculating mortgages. And there might be better ways to also think about this, and to like how to actually calculate these things as well. And so it's very welcome that you contribute and maybe make this better, so that, yeah, like other people can have fun with this as well. So this is one example of net worth calculators, and how you can actually create a very simple app for yeah, just to solve a problem that you have, or like a problem that your friend have, and then you can basically create some like a very easy going prototypes. And as you can see here, like the code is very simple. It's exactly what you usually write in Jupyter Notebook, and there's no fancy way, like no other fancy things to add to it. And for documentations, like Streamlit actually has a very robust documentations, and you can actually just find anything that you want to display here. Like you can see how you can display charts, and you can actually display like JSON data and how to actually create data frames, and everything is very easy with a simple call Streamlit dot, and then that's about it. And the second app that I want to show is basically an app that actually used a model for inference. And so this is an example of a model that you can use to describe an image. And so, as you can see here, this is basically an image that I found on Unsplash. And once you insert this image into the models, and then the model will try to basically predict what's inside the image. Like, so for example, like it's trying to describe a man standing at the beach shoreline and watching the sunset. And we try to find another. Maybe let's try this one then. Yeah, this one is not so good, right? But then it's actually like being able to tell you like there's some blooming trees here. And so yeah, so the way that this model works is basically a clip model from Hugging Face transformers. And the way that this model works is that it's try to embed the image into numeric embeddings, and also try to embed the words, the description into numeric embedding as well. And then it try to calculate the distance between these two embeddings and to see how close and how far they are. And the closer they are, then the closer the captions that it tries to recommend you. And the farther they are, the farther the captions for the recommendations. And so you can easily think of this, like for example, if you want to think about maybe what you can use this for. Like for example, I can think that this could be really useful for people with visual impairment, for example, like someone that needs help with maybe describing what's going on the screen and what's going on the photos of their loved ones they send them, for example. So there are a lot of different ways that you can think about like how you can actually use this and how you can actually maybe think about the different benefits of things like this. And the way that you can actually do this is there's a lot of, let me show you, yeah, the prototype works. So there are a lot of different models online that you can actually use. So you don't have to train the models yourself. You don't have to train everything from the beginning. There are already a lot of models online that you can use, and you can actually like create these apps for. So for example, the app that I just had, like I didn't train anything, right? So I just basically took a model on Hugging Face, and yes, you can see here, Hugging Face is a very good platform hub for all text and natural language processing models. Any natural language processing task you can think of, you can go on here and you can find a model that might fit with your need. So they have like text classifications, questioning and answers, and summarizations and text generations, for example. There's thousands and thousands of models that you can go into and you can play around with, and they have very good documentations on how you can actually use this. And so when I create this model, for example, I basically look into the API for the clip models, and then I basically copy the code on how do you actually use the models. And for example, here, like you can see, you just basically import the transformer models and the clip models, and then you basically reuse the code that they have from their API, and then basically like put in the models that you have for the code. And yeah, so this is the second level of organizations where you actually have an actual functions where you can reuse the different load models and get images. And so as you can see here, this is the functions to load the different models that we have for text embedding and for caption embeddings of the image. And basically just load this model directly from Hugging Face. And then this is the functions to get the image that we have from the URL that we have. And then we do inference on this image based on the models that we have. And then we get, this is the captioned, like how you get the caption for the embeddings of the image, basically. And so this is the second level for organizations of their code and for the image description. And so there's a lot of different, I think, hubs where you can actually find the models. I will actually include that in the final presentations to send out to everyone. But basically, online, there's now Hugging Face where you can actually find all these available models. There's model hubs for genomics and for language processing. And there's also, I think, TensorFlow hubs for all the models that are available on TensorFlow. And a lot of them are actually has to do with art and styling and object detections. It's very fun to play around with. Highly recommend if you have time and when you want to play around and use Streamlits to go on one of these sites and download the models that they have, and then you can maybe try to launch it with Streamlit. And there's one thing that I think we're thinking of doing, because there are hubs for natural language processing tasks, right? But currently there's no model hubs for computer vision tasks. And so one thing that we're thinking about is actually to create this hub for collections of all the computer vision tasks and other computer vision models that are available on the web. And so if you are interested in working on this, let me know, and then maybe you can also work together on this project of building this computer vision model hubs for machine learning engineers and data scientists everywhere around the world. And the last thing that I want to show you is FastAPI. And I try to, so the way that you can use the FastAPI, as I mentioned earlier, is FastAPI is basically the backend language, right? So what you usually can do is you can use Streamlit as the front end, and then FastAPI as the back end. So Streamlit can be the front end, the pretty UI where people interact with your models, and then FastAPI is basically a back end where you can actually like store all the data and have the database, and then Streamlit can query the data database from FastAPI interface. However, as I mentioned this morning, everything broke for me with the styles transfer Streamlit, and so it's basically a Docker issues, and so I could not launch it, and so basically we're just gonna have to do like a very vanilla California house price predictions. And so as you can see, I don't know if I have this launch already. Yeah, so in order to launch FastAPI, it's very simple. You just basically use Unicorn and you launch the app, and then it should be available. Yeah, as an app, actually, like it's as an API documentations. And so I can actually also directly show you the code so that you see where everything is. And so this is the third level of organizations. And this is where you start to break your code into actually manageable chunks, and you actually like refactoring them into all the different pipelines. So for example, here, this is probably the most important file in this folder. It's basically the model files where you actually have a class of the models, and you actually load and you actually pass all the processing of the data into the model. And so, for example, here is the heartbeat. Is basically like to check if everything is good and everything is successful. You load, as you can see here, everything is alive. And so this is the third level where you actually, the way that you do it is actually you only write everything in one file first, and then you start to break them down, and you start to break them down into smaller chunks, and then you start to break them down into these like smaller modules where every modules work on a different thing, right? So one module is just work on the health of the models, and one module is just work on the payload, on the predictions, and one model just work on the predictions on the medium house price and everything. So we can try to see how this actually works here. First, we need to authorize with the API key. And we can start to work. So this is basically a very simple and vanilla data set from California house price predictions. You have data from yeah, so you have basically data on median income of a block in California and median house age, average rooms in the house, average bedrooms, population per blocks, and then you basically create a data sets and you have to create a models to try to predict these the median price of the house. And so, for example, we can try to fill in, and we can try it out. I think, yeah, the median house price will be in the response here. And so this is basically the request, right? So a post request is basically like a request that we put onto the servers to get the queries, to query the database and to get the answers that we want. So for example, we maybe median income in blocks, it could be maybe 7.5. So the median income is actually in tenth of thousands. And so this is basically 75,000, right? And median house age could be maybe 40, average rooms maybe 3, bedrooms 2, population per block maybe, I don't know, 1,000. Average house occupancy maybe 3 people in a house. And block latitude is basically like how far you are from the west. And the further from the west you are, I think the richer is the neighborhood, I think. And this is like how far you are from, I think, from the north. And the further on the north you are, so the richer the neighborhood. And so if I remember correctly, yeah, this is basically what you can, from the data description, basically. Yeah. So you have the data descriptions when I download this model from Kaggle. So when you click execute, then it will try to give you like a median house values of that area. Yeah, and so basically it takes in all of these different factors and parameters, and it tries to predict the median household values. And so, as you can see, this is basically the documentations for FastAPI, and you can very easily use this and connect it together with Streamlit so that you can have this as the backend, and it can feed the model into Streamlit as the front end to query the data and to actually give you a very full-fledged app where you have both the front end and the back end, and you can actually query the different models, and you can play around with the different models and launch the models into productions. So I think a few of you are working also on data sets for your machine learning class, and I highly recommend that you use these tools, Streamlits and also FastAPI, for yeah, maybe launching like a demo app for your class, and something that you yeah, something that you can play around with, and also something that the professors and also maybe yeah, other people might be interested in seeing like how you can actually interact with the data and interact with the data sets that you have. And yeah, I think that's about it from my end. I think maybe we can start with the question and answer. Look at the questions here. Yes, Robert. So we will have, yeah, I will send everyone the slides, and everyone also these different websites as well. So yeah, you can also play around with, and also you can, yeah, create your own apps based on this as well. And like the code is very simple. It's very easy to work with, and it's, yeah, I think it's very fun to play around with as well. I sent this to a couple people to test, and they all quite enjoy toggling with yeah, the network and see how far they will be in 30 years. Yeah, if anybody has any questions on this. Yeah, so as I mentioned earlier, right? So I will send everyone the presentations and also the web apps. And also if anyone is interested in also building the model hub for computer vision tasks, also let me know. And then maybe we can try to think of ways to work together as well to yeah, to make it happen. And I really highly recommend everyone to try it out Streamlit. It's extremely fun to build, it's extremely easy to build, and it's not scary at all. And it really helps, I think, to like really elevate your project on another level, and especially really helpful if you're looking for job opportunities. Then if you have an app like this available on your resume and people can actually interact and play around with, instead of just a Jupyter notebook on GitHub, then I think it really bolsters your chance of getting the job, because you have the ability to deploy a product into productions where people can actually use and have fun with. And yeah, so thank you everyone for joining the sessions today. And let me know if you have any other questions later on. Then thank you, and hope everyone take care and have an absolutely nice day. And yeah, go out and support the Ukrainian team if you can't. I think everyone's gathering in Brandenburg right now for the protest against the Russian war. So yeah, let's go out and support our neighbors and in this senseless war. Thank you so much, and have an absolutely fantastic day. Bye.